Change of base for logarithms, problem type 1. This next type of problem deals with how to evaluate logarithms on arbitrary bases. Most calculators feature two logarithm buttons, a common log button and a natural log button. Remember, common log is log base 10, and natural log is log base e. Those are the only two logarithms available on this calculator. Some calculators may have a button for evaluating logarithms of arbitrary bases, but most do not. So we need a way of changing a log of another base into a log that we can evaluate. And luckily, the process is really not that hard. I'm going to use the definition of a logarithm as the inverse of an exponential function to derive the formula. If log base b of x is equal to a, that's equivalent to saying that x is b raised to the a power. Now, if I take the logarithm of x, by substitution, since x and b to the a are the same thing, then the log of x and the log of b to the a must also be the same thing. Now, using the properties of logarithms, log of b to the a is the same thing as a times the log of b. And finally, I can get a by itself by dividing both sides of the equation by log of b. And from here, using the transitive property of equality, if log base b of x is equal to a, and log of x over log of b is equal to a, it must be the case that log base b of x is the same thing as log of x over log of b. And that gives us the tool that we need to evaluate a logarithm. So, if I want to calculate the log base 7 of 6, using the tools that we just developed, this is the common log of the argument 6 divided by the common log of the base 7. Then I can grab my calculator and it can do the work for me. I can take the log of 6, close parentheses there, close parentheses to make sure it's really taking the log first, and then divide by the log of 7. And I'm overdoing it with parentheses, but please do make sure that you are closing the parentheses that you open. Most of the mistakes I see in this type of problem are leaving a parenthesis out, so you end up taking the wrong expression. Right? Rounding to the nearest 10,000th here, I get 0.9207 or 0.9208, somewhere thereabouts. Right? One more time, I want to emphasize, pay attention to how you're inputting things into your calculator and make sure you're taking the log of 6 divided by the log of 7. Very often, the mistakes that I see on this problem are leaving that closed parenthesis out and punching in something that looks like this, which the calculator then interprets as the log of 6 divided by the log of 7. right? That is not what we want. So be careful and pay attention to how you're using your calculator.